Okay, this is our little introduction to supercontinents. Our mascot is going to be Einstein, this little fluffy guy. And the subtitle for this one is Florida Doesn't Belong, basically. All right, you can get down. There you go. Okay, so let's go. Florida, as seen at this very moment with a hurricane approaching, that's just how it always is and must be. So, think of the continents as like little floating sponges and they're just sort of sliding around and they're it's like they're in a bathtub. They're sliding over this molten magma underneath and they're bumping into each other. And when they bump into each other, sometimes they stick, sometimes one goes under the other, and sometimes they'll bounce off and go back where they came from. And they're being pushed along by volcanic eruptions. So if there's an eruption here, it'll sort of spread the land out, and the continent's just a little floating bit that sticks up on these plates. And so they'll sometimes move apart and together. Like the speed at which they're moving is imperceptible, but over time, for example, the UK is actually moving in to dock again with Europe, which is going to be real embarrassing for all the people that voted for Brexit in just like a couple 100 million years. Oh, man. When they're part of Europe. Oh, terrible. Um, and so over time, there have been these different sort of groups that contain all or parts of some of the continents that you know and love. So, like, here's Laurentia up here, South America. I think this was a bit of North America and Europe, if I remember right. Some of the other parts of Europe are here. The Siberian plate is Siberia, as you know her today. Um, uh, you got South America fitting into Africa, just so. And so, that's what these land masses were called. So if we say Laurentian, or if we say it's from the Iapetus Ocean, that means, oh, okay, it was in the ocean that's between basically North and South America, or what will eventually become parts of them. So looking a little closer, Avalonia is kind of neat because this ends up sort of plastered on the east coast of Canada and also ends up containing some of the landmass that's going to end up over here in England. So you'll find the same sort of early fossils of some Ediacaran organisms actually in both those places because they were just part of the same landmass that had to split at some point. The ocean that's in between here. So after Laurentia actually docks down onto Gondwana, and so this would be in the Silurian period. So after the Cambrian and Ordovician, before the Devonian, you're going to have this big long sort of finger of ocean in here. That's the Rheic Ocean. And a lot of the fossils that you would find in the US are going to be from the shores, like where it was fairly shallow. And then eventually this continent's going to get tilted up a little bit and lifted up. And that's why the stuff that was underwater is going to end up above water, where some of it is now. And just looking at that, you can say, okay, where should we find Silurian fossils? East Coast. Yeah, pretty much. Around where the Appalachians are. And we'll get to the Appalachians here in just a sec. All right, then what's the next thing that happens? So you see you've got this big Gondwana down here, and you got your Laurentia up here, and those things are actually rotating, and they are going to slam together, and they're going to come together to make this giant supercontinent that has basically, we think, all the land in the world on it in a big blob. And so Africa is going to dock right into New Jersey there, which is great, and sort of squish right up against Canada because, yeah, well, Morocco is touching, I think it's Newfoundland over there. And so this plate's going to be moving in roughly this direction, sort of turning around like that. And so they're crashing together. And one thing that's going to happen is that this little chunk down here starts out on the African plate and it's going to get smooshed up into the east coast of America. And if you know that shape, that's where Florida is. That's Florida. So Florida actually starts out on the African plate. Here we're going through time A, B, C, D, and gets squished on there. And then the squishing actually is what causes a lot of the Appalachian Mountains to form as we just sort of fold up the continent with the force of Florida being slammed in. It's not just Florida, it's bits of Alabama and Mississippi as well. So, yeah, maybe even a bit of Louisiana, actually. All right. So it creates this thing, the mini continent that broke off from Africa is called the Suwannee mini continent. A terrain is the fancy word for it. And so the suture zone is where it's sort of squished into the North American plate. And then you get this sort of line of folds running right over here, which is where all the land gets sort of bunched up. And that's going to be part of what lifts some of these rocks out of the water. It's just we're crushing the continent like you're just pushing two pieces of paper into each other because the forces here are massive. Yeah. All right. So if you were to take Pangaea and map the modern world onto it, see a lot of weird stuff. So Saudi Arabia still mostly coastal, but this peninsula and Turkey, which are attached, are actually nowhere near the rest of the stuff that they are normally supposed to be connected to. So you can see this is going to break off and tilt about like that. Africa is going to move down here. The North American plate is going to break off. South America is also going to break off. They're going to go over on this side. And then Russia is going to come down. That's going to rotate. And China, look at that. China's on the near enough on the North Pole at this point. That's going to swing all the way down here. That's like the fast moving edge of the door, if you like, when the door is swinging. And so these are going to come together. And yeah, Iran is so far away from Turkey now, but not for always. And this is when Antarctica is still part of this Pangaea supercontinent. And so this comes together around 335 million years ago, which is going to be around the Mississippian period, which is the lower Carboniferous. It says upper, it means lower. Let's change that. There we go. Perfect. Yeah, just as intended. And it is then only going to break up much later. So it's going to break up over the past 200 million years. And you're going to see cracks forming right just after the end of the Permian in the Triassic. And then by the Cretaceous, like the end of the age of dinosaurs, when everything goes kablooey and the big thing from space comes down, you get the continents, and they're roughly squished into recognizable shapes. But look at India, still freelancing, still hasn't found a home, but it's headed somewhere right there. When those continental plates get around to moving. And so the plates are moving a little bit, but the continent, remember, is floating on top, so they can move. And it seems like they move faster when they're just sort of one plate's going under another, or we're squishing things up under the ocean. All right. So that's what's going on now. And so what are we doing? Well, at the moment, there is a mid-ocean ridge, which is like a great big crack from which fiery lava comes out, and it pushes the plates in different directions. So the North American plate is being pushed this way toward Europe. The Pacific plate, which is like, Japan's on the other edge of this, is being pushed farther away. And so, yeah, we're getting farther apart from Asia and closer to Europe. Yeah. Just through the movement of the plates. There is something similar that's happening on South America on the west coast. And it's, that plate is sliding over the Nazca plate, named after like the Nazca lines and Nazca people, I guess. Yeah. So there you go. Florida. Yeah, you always knew it didn't belong. Now you know why. All right. Thanks very much. This has been Pangaea.